China's Chang'e 4 lander and its robotic U-22 rover have found that the geologic history of the moon's far side is far more complicated than scientists had originally thought. A report in the journal Nature has found that levels of the mineral olivine near the landing site don't match what was expected. It was thought that a molten magma ocean covered the lunar surface for much of its early history. As the molten ocean began to settle, cool and solidify, lighter minerals floated to the surface while heavier minerals sunk down to the bottom. The crust eventually solidified over in a sheet of Mare basalt, encasing a mantle of dense minerals such as olivine and pyroxene. As asteroids crashed into the surface of the moon, they cracked through the crust, ejecting pieces of the lunar mantle. Understanding the composition of the lunar mantle is critical for testing whether a magma ocean ever existed, as the hypothesis suggests. And that's important because the evolution of the moon will provide a window into the evolution of the Earth as well as other terrestrial worlds. That's because the lunar surface is relatively untouched compared to the Earth, whose surface has been dramatically reshaped by things like erosion, plate tectonics and volcanism. Chang'e 4 landed in the moon's South Pole Aitken Basin, the largest impact crater in the solar system. It's also the first spacecraft to land on the moon's far side. See, the moon is tidally locked with the same side always facing the Earth. There are great differences in the composition, terrain, structure, and the age of rocks between the lunar near and far sides. The far side is very mountainous, rugged and thickly dotted with impact craters, giving it a very different appearance to the large, flat, mare-covered near side. About 60% of the near side is covered in mare basalt. In fact, of the 22 lunar mare, 19 are located on the near side. The lunar far side is covered in lunar highland anthracite. Scientists don't fully understand the reasons for this geological asymmetry between the near and far sides, although they infer that the lunar crust is thicker on the far side than the near side. But because it always faces away from the Earth, the lunar far side is more difficult to study. Landing on the far side places any probe out of direct radio contact with mission managers back on Earth. China's solution involved first placing a communications satellite named Magpie Bridge into the gravitationally stable position in space known as the Lunar Lagrangian 2 position, 65,000 kilometers above the lunar far side surface. From there, Magpie Bridge can relay communications between the Earth and any far side lunar lander. This was followed by the launch of the Chang'e 4, which touched down earlier this year. The huge 2,500-kilometre wide Aitken Basin is some 13 kilometres deep and peppered with younger impact craters. Chang'e 4 and its U-22 lunar rover have been collecting spectral data samples from the flat stretches of the basin, as well as from the other smaller but deeper impact craters within the basin. The researchers expected to find a wealth of excavated mantle material on the flat basin floor, since the originating impact penetrated deeply into the original lunar crust. But instead, they only found faint traces of olivine, the primary component of Earth's upper mantle. The absence of abundant olivine was a real concern. However, as more and more samples from deeper impacts were taken, greater amounts of olivine were found. Scientists now think that the lunar mantle consists of equal parts of olivine and pyroxene, rather than being dominated by one over the other. Named after the moon goddess in Chinese mythology, Chang'e 4 was originally built as a backup to the 1,200-kilogram Chang'e 3 lunar lander, which touched down on the Bay of Rainbows on the lunar near side in 2013. And like Chang'e 3, Chang'e 4 also carried a small 140-kilogram six-wheeled U-2 or Jade Rabbit rover, the U-22, to explore the craggy and complex terrain of the surrounding landscape. By the way, Jade Rabbit was the moon goddess's pet. The U-22 rover was deployed onto the lunar surface 12 hours after the Chang'e 4 touched down. The rover will need to explore much more of the basin to better understand the geology of its landing site and to fully understand the composition of the lunar mantle.